All right, looks like we've got folks starting to join. Welcome, everybody. It is fantastic to have you. We'll give it a couple of minutes just to make sure that we've got kind of a quorum here, and then we'll look forward to diving in. All right, we got more joining. So, yeah, we'll get started here. It looks like we've got a great group. I know we had a number of folks register. There's a lot of people eager to learn more about the future of drone inspections, and so we've got fantastic hour here set aside for this webinar. And what we're going to be talking about is building scalable, efficient data pipelines for intelligence with drone inspections. And so we're talking drones, data, intelligence, and just to even start, when we're talking about drone inspection, what exactly do we mean at a very fundamental level? We're talking about using a drone to collect visual data on the condition of an asset. And so we're gonna, over the course of this next hour, start off with just some introductions, so you get to know our panelists and the perspectives that they're coming from their respective organizations. And then we're going to take the bulk of the time and work through some Q&A just here amongst myself and the panelists, and kind of use the framework of past, present, and future. So past, present, and future of drone inspections. And we're going to lean heavily, especially on the present and the future, because the companies that these folks are representing are really at the bleeding edge of innovation today and tomorrow. And so we're going to look forward to hearing from them on a range of topics. And then at the end, we'll have 15 minutes for live Q&A. So definitely be dropping your questions here within Zoom, and we'll look forward to getting those at the end. So yeah, the outcome that we hope you all get from this hour together is that at least, if you're involved in a drone inspection program, that you've got at least a couple takeaways that will help you just further innovate with the data you're collecting and better serving your organizations. And so you're going to hear from, again, some experts that are deep into this space and learn some things, hopefully. So just a final bit of housekeeping. So we will have some polls that pop up during the webinar. So please participate in those. Those will feed into our discussion. So don't be surprised if that window comes up. But let's do it. Let's take it away. So let's get going with some introductions to start. And again, we've got representatives from Elsight, Drone Deploy, and Skydio. And let's start with Ben. Ben, welcome. And why don't you just tell us a little bit about Elsight and your role at the company?
Hi. Well, first of all, thanks for having me here. Elsight provides a connectivity solution for drones and UAVs for basically any unmanned or uncrewed vehicle, whether it's air or land or even sea, as long as they're within range of mobile networks. Essentially, what we're able to do is we're able to bond up to 4 unique different mobile networks, as well as RF and SATCOM communications into one bonded network, secured obviously by a VPN taken directly to our cloud. We're able to provide absolute connection confidence, basically taking all these networks, meshing them into one, and providing what is in essence a massive LAN cable, a massive network cable connecting your command and control center to your drone, to ensure that you never lose connectivity with your drone, you never lose control, you never lose actual remaining in contact with them. And the possibilities for drone inspections and many other industries are clearly very plain to see, and we're really excited about them.
Awesome. Thank you, Ben. And I think you're joining us from Israel today, is that right?
Correct. I'm joining from Israel, and actually up to about an hour and a half ago, I was actually out in the field. Israel is running what's known as the Na'ama project, which is a project integrating drones into the urban airspace. All right, it's about aerial mobility in the urban airspace, and I was out all day visiting our customers, our clients who are using the L-Site Halo in their drones, both from the UTM aspect as well from the drone aspect themselves, whether it's with 5G support or dealing with the remote ID or just the actual connectivity themselves. So I was out in the field. We were taking pictures, taking videos, talking with
Awesome.
the clients, just hearing what they had to say about the L site, and we're really excited.
Yeah, awesome. It's great to have global participation here, talking about drones. So Jay, welcome as well. Why don't you tell us more about Drone Deploy and your role there?
Yeah, thanks, Paul. Thanks for having me as well. My name is Jay Malakala. I manage our solutions engineering team over at Drone Deploy. I'm based out of New York City. Been with the company for about 4 years now, but I've been in the drone industry for probably about the past 10 years or so. I started as a hobbyist myself, building my own hardware back in the day before moving into the software space over the past few years. For those of you that aren't aware, Drone Deploy really is an end-to-end reality capture platform. We started in drone technology, with our first product back in 2015. And since then, we've really evolved to all things reality capture. And so that really breaks down to two key aspects of our product. On the data capture side, we have autonomous tools that support about 80% of both aerial drones as well as ground robotics today for consistent, reliable, repeatable data capture. And within our cloud platform, we give our users the tools to be able to view a digital twin of their site using our photogrammetry engine, and really being able to assess or inspect or analyze their site the way you would if you were physically walking your site in the real world. And so our focus is really how do we centralize all visual data in an easy to consume manner, as opposed to looking through thousands of photos or spreadsheets or documents to be able to analyze your site. So thanks for having us, Paul.
Yeah. Thank you, Jay. And then last but not least, Colin from Skydio. Same intro questions to you. Go for it.
Yeah, absolutely. Thanks, Paul. Appreciate it. And good to see everybody. Looking forward to the conversations. Like Jay, my role at Skydio is on our solutions engineering team. And I always like to say solutions engineers have the best job when it comes to drones right now, because we get to get out there in the field and see what the needs are of our users, and then also take that information and relay that back to our product team to help guide what our products are, how they're evolving, and what new features we're developing, etc. So we're having a great time making sure our folks are successful in the field and also looking towards that next generation. For those of you that don't know much about Skydio, we are the largest manufacturer of multi-rotor small unmanned systems in the United States, and we've been around since 2014. We take a software first approach to all of the hardware that we develop, and a big focus on autonomy, as we'll continue to talk about more today. We definitely feel that autonomous capture is the future when it comes to unmanned aircraft systems, and we're proud to be leading the way and developing that technology to help facilitate those end-to-end solutions that Jay and Ben were talking about.
Yeah, awesome. So for everybody, if you haven't checked out the YouTube pages for the three companies here, that's a great way to learn. I know I was in the past week looking at different stuff that you guys are all posting, and it really brings to life the technology and the innovation that you're working on. Just a quick introduction on myself. I actually started at Cloudfactory as a solutions engineer as well, so we've got that similarity. Cloudfactory now is a data annotation provider for machine learning and business process optimization. And we work in a number of industries, but one of our high growth industries is actually serving the drone industry. And so just to kind of, as we transition into the discussion and some of the questions about past, present, and future, before we do that, I'm going to share one thing on my screen, again, just as kind of a framing for whether at Cloudfactory or other companies in this space, just where we're seeing basically how this data is used for intelligence and for machine learning. And so here's just a quick visual And so we've identified, at least four ways of perception and data processing is being used. And so one, in automated navigation. So that's actually right around the ability to navigate, assets and detect and avoid. Secondly, in digital twin creation. So I think you heard Jay talk about digital twins there. Third, post-processing data. So gleaning insights from the imagery or the other sense data that's collected through the flight. And then four, real-time data processing. So using that AI to detect anomalies and immediately notify relevant parties. So again, just a visual here, because I know just even the drone landscape is a big one. We're narrowing in on drone inspection, and then even within drone inspection, right, it's largely about the data and how to utilize that data in the operation of drones for inspection. So hopefully this helps to make things a bit more concrete. And then the last bit here is I also want to just bring up a poll that we did on LinkedIn leading up to this webinar. And so this was asking, to what extent are you in the audience using AI or data processing in your drone inspection today? We just want to get a baseline for that. And so you see the responses there up until today. And looks like the biggest response was in the area of automated navigation. So that's interesting to see. And as we work through the questions, we'll probably get some other data points again about that part of the inspection process and the role of data. So cool. All right, so let's. We're not going to go deep into a history lesson here, but Colin, I would love to just initially talk about why use drones in the first place for inspections. What was the benefit initially of inserting drones in that process and replacing what had been kind of the prior way of getting things done?
Yeah, absolutely. I appreciate you starting off with one of those softball pitch questions, Paul. That's pretty straightforward. I think really initially it came down to ease of accessibility, right, and also ways to improve safety. There's a lot when you talk about critical infrastructure. There's a lot of areas that are dangerous to access and also hard to access on a routine basis, which is why traditional methods of inspection, actually having to send people in there to look at it, or talking aerial inspections using helicopters and things to do that, they didn't happen all that frequently for those reasons. It was expensive to do. There was a lot of human risk involved with that. And so I think, a drone provided an excellent tool to be able to get that visual look, get that eyes on some of these components, some of this equipment, et cetera, that is definitely critical to an operation. But, getting there and looking at it regularly was a challenge from both the safety and accessibility means. So, really drones opened up that door. A lot less risky to fly a drone, especially in certain types of areas, and also a lot easier and cheaper to do it on a more frequent basis. Yeah, and
Colin, we'll probably talk a lot during this session as well about just from an industry perspective, right? I mean, drones are used across a lot of different kind of verticals. And so what were even some of those, first industries that started to adopt drones for use of inspections?
Sure. For the inspection use case, I think there was some variation just depending on where you were. Right now we work pretty heavily with electric utilities, and a lot of the electric utilities we work with, had very early programs as well that were started up through their aviation divisions, because they had been flying helicopters and things like that, to inspect lines. So they had the knowledge of the FAA and some of those earlier regulations before Part 107 to kind of do things a little earlier, more of an R&D type approach, proof of concept types of things. You also had structural inspections that started fairly early. I think that kind of spawned out of the use of drones in real estate marketing and home inspectors, building inspectors, et cetera. They were able to see, hey, this, yeah, it can take pretty pictures, but maybe we can also use this to get more detail on, the degradation of things that, we're interested in from an inspection purpose. So you had it there as well. And then, the at least here in the United States, the FAA, also started to inject some money through early pilot programs with the US DOT, related to some of our transportation resources. So railways were kind of early adopters in that inspection front. We also saw telecom starting to get in there because they've got tall assets that, again, hard to get up there and see, what everything looks like. So, I would say there was a mix, for sure. And all that we've seen happen since then is just, greater, more and more adopters, starting to look at the technology as a solution.
Yeah. Well, cool. And we're already going to start some of the interactive polls, again, as we're talking about just how long folks have been using drone inspection, because I know a lot of the audience here are directly hands-on in programs. So we've got for our first poll up here live, and the question is, when did you start using drones for inspection? So take a moment to answer that in a way that reflects your experience, and we'll revisit it here in a bit. So cool. All right, Jay, just, so maybe just a kind of a follow-up question, and let's focus in on autonomy. So can you just talk about some of the first applications of autonomy specifically?
Yeah, sure. I know you mentioned you wouldn't do a history lesson. Maybe I could do a short history lesson here too, Paul.
Yeah.
Drones and really just aerial data is nothing new. It's actually been around for a few centuries now. If you look up a story online, some of the first drones that people used to capture aerial photographs were actually pigeons back in the early 1900s. There's a German inventor by the name of Neubronner back in, I think, 1840 or so. There was using pigeons to capture photographs because he was just curious to see where his pigeons were going when sent out honing pigeons. And so he developed a little harness for pigeons with a really lightweight camera, and he would just set up an automatic trigger for those photos to be captured every 30 seconds. He even submitted a patent for that little harness that he made for pigeons. And for a brief period, they actually used it during World War I to try and capture some images behind enemy lines. Now, this obviously didn't last long. The unreliability of flight paths using pigeons and the quality of the aerial photographs just made it obsolete. It wasn't an invention that actually lasted long. But it kind of showed that there was some potential for aerial photographs beyond what they'd already been using at the time. And they've been using balloons, hot air balloons, and other types of devices to be able to capture aerial photographs. And we've come a long way since then. But even the first drones faced a lot of these challenges. If you had tried to fly a drone about a decade ago, as I have, you would realize manual flight using drones was incredibly complicated at the time. And reliability was a whole another question. I've at least had half my drones fly away or crash about 10 years ago. And we've come a long way since then. So we focused on just reliability and quality of the imagery. And for us as a company, it was really key that our customers capture quality data. And for that, they needed to have a repeatable, reliable, and consistent data capture. And that's really where we started with our first product back in 2015. We released an autonomous flight application. And today we automate all things data capture, including aerial data as well as ground data, because we really understand that repeatable, reliable, consistent data capture is what actually makes the data consumption more valuable. And to your earlier question as well, with regulations loosening up, like Colin had mentioned, what we had seen early on was prior to loosening regulations, we saw a lot of companies within agriculture or aggregates and mining start to adopt this technology because they didn't have to worry about airspace restrictions in their area. And then when the FAA in the United States released Section 333 a few years ago, it really opened up the ability for individual operators to now begin performing flights in more urban environments. So we saw greater adoption from some utilities companies as well as construction companies. And in the past few years alone, we've even seen energy companies start to open up and adopt drone technology for inspection of a variety of different assets, anywhere from refineries and well pads all the way to massive commercial solar farms, wind farms, hydroelectric plants. So the industry has really evolved quite a bit since the early days of pigeon flights in the 1840s.
Well, Jay, I saw that you've got an aerospace degree, so I don't know if that was maybe chapter 1 was on pigeons, but I appreciated that lesson as an econ major. I'm going to stick with you just as a follow-up, Jay, because now we're kind of getting more into the present, and you were alluding to again some of the data that's captured. Can you just talk, I guess, about present day drone deploy? Like, what are some of the key industries you're seeing who are using drones in their inspection operations? And let's stick with the data. So what data are they collecting, and essentially, like, why? What information are they trying to get from that data?
Sure. Like I mentioned earlier, a big part of it is, we see this industry in about 3 stages, especially for us. The first piece is autonomous data capture, and that can be just simple photos and videos, but capturing that repeatably, reliably, and consistently. So one of the reasons why we also launched a partnership with Skydio just a few years ago, because we share a similar vision on autonomy and autonomous data capture. The second is really having a much more holistic perspective of your entire site. Looking through thousands of photos is not necessarily going to save you more time than just having someone go up there on a ladder and take a look at it with their own 2 eyes. And so it was important that you can geolocate all this information and understand where that information actually exists. And so one of the first things that we did as a company was we understood that the aerial images are only going to be valuable as the outputs that are created. And especially back in 2015, we had customers that were looking to generate any variety of insights from this data, and the industry as a whole just wasn't quite there at the time. And so we launched our own photogrammetry platform that essentially took all the thousands of images that you can capture, whether it's from the air, from the ground, and reconstruct a digital twin of your site. So now you're looking at just one asset, one model of your site at any given moment in time, but you could be looking at thousands of different images, videos, panoramas, or different types of data products in that one single model. But you have geospatial context for where that individual picture exists. And so from there, we've seen a lot of adoption within those industries that I mentioned earlier. So we have Corteva, for example, is one of our larger customers that's enabled 1,000 of their agronomists to go out and scan their customers' fields to do something as simple as crop scouting, identifying yield, identifying pest damage or wind damage, and being able to provide that information to their farmers, something that they either had to fly a plane over or had to physically walk the field in order to get that information. Within construction as well, we've seen a significant amount of adoption. Initially, we see customers start off, they'll capture individual photos or just individual videos to measure changes over time. But creating a digital twin of their construction site on demand has meant that they now have a data set that they can view on a day-to-day basis or week-to-week basis to see changes in real time. And so we have customers that are building massive data centers. We have a few customers that are building some new stadiums around the world. And we have other customers that are doing anything from commercial or large residential projects to civil projects as well, roadways, bridges, canals, whatever that might be. And then within energy, again, we've had a lot of different customers use us for different use cases. One of our investors is actually Invenergy that launched us into the energy space a few years ago. And they have about tens of thousands of acres of solar farms spread out all across the Midwest. And so they needed an easy way not only to be able to monitor the construction of these large solar farms, but also to inspect them once they've been installed. And so that was our entry into the energy space. And then since then, we've seen adoption from quite a few customers within energy across all different energy subverticals that are using both all types of data, whether it's aerial data, ground data using ground rovers, or even just capturing mobile photos using their phone.
Yeah, I appreciate those examples. And you really get to see the breadth really of the applications across industries. Just listening to you. So I'm going to get to Ben here with a question next. But before we do that, let's just pop open the results from the last poll question. So again, this was when did you start using drones for inspections? And looks like the greatest number is 2+ years ago. So yeah, we've got 41% of the attendees who have been doing this for at least a couple of years. So that's good to see. We'll keep getting deeper into the weeds and details. So hopefully, that's helpful for those experts. So Ben, I'm gonna turn over to you, and let's talk about beyond visual line of sight BV loss, and would love to hear from you just kind of where we're at today in terms of the capabilities in that area, and why is that important? How are we gonna benefit as an industry from continued capabilities in that area?
The answer is very simple because, to look at it from a very, very high level, humanity has always tried to go farther and do more and, get better at what it is we're doing. So we've always had this urge. We start with, okay, we see what we're doing with line of sight flying. Then we have ELOS, extended line of sight, where you don't have to remain in perfect visual contact. The range gets a bit larger. But then we move on to BV loss, beyond the visual line of sight. And this is where the future really is going to be, because beyond visual line of sight doesn't mean that I'm standing over here or Jay's standing over there and he's operating a drone and he's going to take control of it. It's going to take off. He's going to run his inspection of, the closest 3 utility towers, and he's going to come back. All right. The future is a world of drone network operation centers, DNOCs, where you're going to have a staff of people. You're going to have 3 or 4 people that can operate hundreds of drones over a region that's thousands of square miles large. All right. And it's not a question of one person for one drone. All right. Once the BV loss is approved by the FAA and once the bugs are worked out and the kinks are all settled, right, we're definitely going to see massive control of drones by a number of individuals, which is not that large. Right. And that's where the future is taking us. And that's why BV loss is important.
Yeah. Yeah. So, and let's, just maybe talk more about the data that's needed to actually make that a reality. So, for example, like why is data connectivity, accessibility so important when talking about being able to scale in that sort of way?
Right. For the simple fact that there is a certain level of autonomy which you are able to provide your drones, but in the end, and currently this is FAA regulation, your drones need to be under control. Your drones need to be connected to the ground base, to the command and control center. Again, even if it's not a question of one-on-one, if you have a computer system that's assisting you, all right, the fact is that you still need to maintain connectivity of your drones so you can take control of them if you need to double back and take another look at something. If you see that there's some sort of error, some sort of a fault or failure that's requiring you to land, so you want to try and land in a controlled manner as opposed to crash landing. All right, anything that you want to do with the drone, whether it's inspections or beyond, you need to remain connected to your drone at all times, both for regulatory reasons and just for common sense reasons, that you don't want to send off your drone and then not have any idea of what's happening to it.
Yeah. Yeah. Well, so let's actually bring up the next poll, and this is getting into, again, more the data side and the types of data that folks are collecting via drone inspection. So I think that's maybe multi-select, not sure, but take a look at that and answer to help give us a flavor of what you all are capturing. And so let's keep moving. So Jay, I'm going to go back to you. So I think, when it comes to data in drone inspection, domain, there's a lot that needs to happen in terms of pre-processing and preparation and different steps of kind of the workflow. Can you break that down for us a little bit of basically how does data need to be processed and prepared to provide some of the meaningful information that we've alluded to so far?
Sure. And you know what? I know there's a couple different ways we use processed. Internally to drone deploy, for us, that really means our photogrammetry processing to create the digital twin within the product. And photogrammetry itself is nothing new as well. It's been around for probably about 2 decades or so, and there's been quite a few software platforms in that space. And like I alluded to earlier, it's essentially just the concept of taking individual photos, and it started with just ground-based photos and being able to reconstruct a 3D model, 3D point cloud from that data set. What we've done internally is, we want to be able to optimize for both quality and speed of the photogrammetry process so that our customers can get more consistent, reliable, and repeatable data. And so our real niche in this space has been one optimizing for aerial data capture first, which can be complicated. And that starts with consistent, repeatable, reliable data capture. The second is knowing that our customers are not photogrammicists. They don't need to understand how to be able to take these individual photos and be able to reconstruct a digital twin from it. They have day jobs. They're asset managers, they're quality control managers, they're inventory managers. They've got their own day jobs, and so we want to make that process really simple for them. And so what we did about 4 years ago is we launched our own photogrammetry platform. We've got an in-house dedicated team that continues to improve that process, where we will take the individual images, videos, panels, whatever that might be, internally. We'll automatically identify the types of data products that you're hoping to get from it. For example, if it is the digital twin, or if it's an interior 360 walkthrough, or if it's progress media or individual inspection photos. And then we will automatically create all the resulting data products within our photogrammetry pipeline so that the user doesn't have to. That'll include the 3D model, the point cloud, the elevation files, the contour files, the plant health data for some of our customers, the terrain models. All that is automatically generated within the platform. And again, optimized for speed and accuracy of that data. And so we've actually embedded, and this will lead into probably some of your future questions, we've embedded a lot of AI and intelligence internally within our processing pipeline to make that happen. So something such as identifying the types of data that you're uploading and identifying what the outputs are, that's something that our vision team works on today to automatically identify. For high accuracy mapping, for some of our customers within construction who care about the accuracy of the data for them to do earthworks measurements or volumetrics against, we've embedded a lot of intelligence to automatically identify ground control points, to be able to identify their reference systems that they're using in many cases, and even doing automatic alignment of data sets over time on the back end, regardless of if you're using a drone or another device that has poor GPS connectivity like your phone or most drones in today. And so we've embedded a lot of intelligence within that processing pipeline. That really means at the end of the day, for a lot of our customers, within about an hour from initially capturing data on their site, they're able to get a digital twin of their facility, their asset, their farm, whatever that might be, with all those resulting data sets.
Yeah. And, for data preparation processing, I mean, you talked a lot about the level of kind of automation that you all have built in. Are there still certain parts of that process where it does require some human touch, even if it's a light touch along that whole kind of data pipeline, just to still make the magic happen, right? Combining kind of the machines with humans in some way.
Sure. We do see some customers capturing manual data. I know it's one of the questions in the thread as well. And really that comes down to if you're inspecting something very particular and you're trying to identify a change in a very specific area, just aerial images that are automated may not be enough for you to be able to get that level of fidelity. So for example, we've had some roofing customers ask, can we identify hail detection on roofs? That is an incredibly difficult challenge. Now, it might be easy for someone to climb up on the roof, lift up a shingle and identify that damage, but using drones with computer vision, with visual data is actually a really complicated problem to solve. And so that's the scenario, we don't see come up as often currently within our industry today, because it is a really complicated issue to be able to solve using what's currently available within the market. But really our goal there is, the autonomous component is absolutely critical, because what we want to do is be able to amplify 10 inspectors' work in a much shorter period of time. So the pilot or the autonomous tool that you're using remotely should be able to capture the data that you need for you to conduct that inspection from your office that can be located halfway across the world, or to invite your team of inspectors to inspect whatever it is that they're looking for. You can't rely on just one operator on the ground to be able to do all of those inspections individually, because then you're not really getting the benefits of using autonomy or using drone technology. So the autonomous component is absolutely critical there. But we do have customers today going out and capturing manual images, but we want to be able to reduce the manual component as much as possible.
Yep. Cool. Well, let's bring up the results of the last poll that was about the types of data being collected. And so, yeah, you see the results there. To our panelists, anything that seems surprising or stands out from kind of the distribution of answers here? RGB being definitely the highest.
No, that looks pretty consistent, I would say, to me anyway.
Yeah, I'd say so as well. And I think, increasingly as you look through this list as well, cost of hardware, I'm sure, is a big reason for starting with RGB and then going to some more advanced hardware. Yeah.
Well, cool. So we're getting into the future here. And so there's certainly more and more AI likely ahead. And Colin, I just would love to hear from you. I know Scadio's developing lots of AI features in its drones, and what are drones capable of today, and how do you think that's going to be evolving here in the future? What are the future possibilities as more and more AI becomes baked into these drones?
Yeah, I think there's two ways to look at it. I think one, you've got more to what we're seeing as the regular here and now, which is that navigation piece that folks were mentioning in the first poll that we took, and where they're using the autonomous type operations right now. And at Skydio, that's really always been our focus. Our founders started the company by developing a cutting edge visual intelligence system that incorporated multiple different layers of AI into it to allow a drone to fly more safely, even if it was still being, we'll say, directed from A to B by a pilot, fly more safely in really any space, regardless of the complexities and things that were going on. A lot of the drone systems that we see in use today are dependent upon GPS connectivity, still, and dependent upon, magnetometers to know which way is north and things like that. And that does still create some restrictions, even though we can program flights based on GPS coordinates and say, fly this pattern, from A to B to, et cetera, and even, start to throw in some altitude variation there as well, as we get more accurate, with the Z-axis data in our GPS receivers, and we're incorporating RTK and stuff into these systems as well. Really getting down and dirty and doing things indoors, underground, in complex areas where hazards can move and change as the flight is progressing. That's still a challenge for a lot of different manufacturers, and that's really, I think, where we have always tried to lean in and have the biggest impact. So, from a navigational standpoint, you can think about a Skydio system as sort of like a Tesla when you think about, the autopilot capabilities and things versus, just some of the more adaptive cruise control features that you find coming out on normal vehicles right now. As we know, there are a lot of people that have put their Teslas in autopilot and sat back, and, the ones that didn't end up on the news, there are many successful journeys that were accomplished, purely with that autonomy that exists. Not saying, we're not still mindful, but, we can see where things are going. The other way I think to look at it is, when we talk about baking in autonomy with, the data piece of all this as well. And, what data can we process on the drone immediately in real time versus, establishing the data pipelines where we take the information that we're capturing and we send it, to another software solution or another technology partner, that's going to be doing that processing as well. And so, we're seeing two things. One, we're seeing LTE radio capabilities, built into the aircraft, so that in terms of connectivity and ease of transfer of that data, in real time, we're helping to facilitate, that more. And I think you will continue to see more of those integrations, with the cellular LTE infrastructure into the aircraft themselves. But also, when you look at the architecture of the aircraft, one of the reasons, or one of the benefits that we run a 256 core GPU on board the drone, our systems, the Skydio systems, other than obviously facilitating our environmental awareness and adaptability, regardless of where we're at, it does also give us the capability to leverage that and do more onboard processing to then, facilitate the speed at which a final deliverable can be given, to whoever a decision maker is that's going to be responsible for that particular program and using the information that the drone is picking up. So, we're heavily involved right now, both in maximizing our onboard compute power, not just for our in-flight navigation, as we talked about, but also from a data processing point of view. But then also recognizing that we can't do everything, and there's no way that one company can try and do everything. So through partnerships, like the partnership we have with Drone Deploy and others, also focusing on those data integrations and establishing those data pipelines so that we can, start more seamlessly pushing that data over and then letting a partner take over on the back end to produce those deliverables, in a smart and efficient manner.
Yeah, cool. And so when I hit both Ben and Jay as well with this last question before we get into the Q&A, but just similarly, we're in 2022 and looking into the future. What are some of the things that you're seeing on the horizon that you're excited about? And I think more people will kind of start to see and realize the benefits of. And so Ben, I'll let you start.
Right. So I mentioned this earlier before. I mentioned our vision, which, like we said, we see drone network operation centers, and we see a fleet of drones being used for inspections and for other things. Looking towards the future, end of 2022, 2023, and beyond, I realized that the first thing that we really need to take a look at before anything is we need to look at the regulation, see what the FAA, what the EASA, what the local aviation authorities have to say about BVLOS drone operation. I think everyone is more or less aware that the BVLOS drone operation is coming. They're just not quite sure yet how to handle it. So I think the future is going to see a wide expansion of the use of drones for inspections, and as I said, for other purposes as well, for deliveries. We know that Drone Up and Walmart are working together. We know that obviously Google and Amazon are also moving forward with their drone programs. So I think that there definitely is going to be an increase in the use of drones, but it's going to be dependent on and determined by what the regulatory agencies have to say.
Yeah, Yeah, Jay, what do you think we should be on the lookout for here in the coming year or so in this field?
Yeah, for us, we these days we use the term drones very loosely, and really at the core of it for us is automated robotics. That's really what a drone is at the end of the day. And so that's with our launch into ground robotics last year. We acquired a company out of New Zealand called Rakos as part of our ground robotics division, because we see that data capture autonomy needs to be holistic. It can't just be from aerial data. It's got to be interior data, exterior data, and in really complicated environments. In fact, it's even exciting to see, we don't do anything with beyond visual line of sight with our drones today, our aerial drones, but our New Zealand team today has our spot robot in our office in San Francisco coordinating on an autonomous schedule, and they can monitor and control it remotely, which is already interesting to see when you've got a four-legged robot running around the office. That's one component of it. And the second is actionable insights. This data is only as valuable as the decisions that you're able to make off of it. And so today we have customers that are integrating our data with other tools to automatically identify issues as opposed to manually identifying those issues within our platform. And we hope to be able to automate resolution of those issues as well on a schedule. And that's where our robotics tie-in really comes in. We don't see robots just being used for data capture, but we see robots being used long-term for resolving some of those issues as well. And so today we're focused on just visual data capture, but long-term as well, we'd be looking at, once we've identified these issues, how can we leverage robotics automation to be able to go out and fix these issues entirely remotely, as opposed to just identifying the issues.
Yeah, it's a great way to end. Kind of, I think the panel section is just right. It's not just the data; it's what you do with it and how you're actually using it to solve real problems and make things easier for people. So we did get some questions I see in the chat. So thanks for teeing those up, and so we'll pose some of these to the panel here and get their perspective. And so one question is just it's about I guess I'll just read it exactly. What percentage of inspections within each industry are you seeing being done autonomously rather than pilot flown? So there's a lot of different industries we've talked about, but maybe somebody from the panel that wants to take that and maybe just take a particular industry and maybe compare what they're seeing in terms of autonomous flight versus manual kind of pilot flight.
Sure. I can jump on one real quick, or a couple. I guess I'll talk about telecom first. And telecom, there's different groups and different stakeholders that are using drones within that space. You really have two types of inspection-based operations. One is the generation of that digital twin that stakeholders are going to be interested in, both the site owners that lease the space to carriers, but also the carriers themselves who put their equipment up there. And the carriers are going to be interested in making sure, obviously, the right equipment, of theirs is up there, and also that it's aligned and oriented properly so that it's giving, the best coverage that it can be for their network assurance folks, things like that. And then, your site owners, the ones that are leasing the space on those towers, they're kind of looking at it like a landlord and making sure that the stuff that should be up there is up there. And if anything that is up there that shouldn't be up there, they need to figure out what contractor installed the wrong thing or what was going on. So from a standpoint of the data then, and autonomous versus manual, usually the digital twin capture, that is largely autonomous. They're gonna set a profile, the drone's gonna fly some type of orbital pattern, collecting those images in a consistent way, and then it's gonna go into a photogrammetry tool, like Drone Deploy and others to generate that digital twin. From a network assurance standpoint, though, there is still a large group within the telecom industry where, let's say there's, an issue, right, with coverage, and, they're sent out to figure out what's actually going on. For those folks, they probably don't need to generate a full digital twin. For them, it's going to be faster to just take the drone up, look around at the different critical areas that they need to look at and figure out, is something unplugged, is something blown out? Is there some damage that's occurred because of a storm, et cetera? So, I would say, that's kind of the breakdown that we see within telecom. And I could talk about others, but I'll pass it to the other folks to see if they've got something else to add.
Yeah. Anything to add from Ben or Jay there?
I think Colin, summarized it pretty well, as is. It really comes down to, are they looking at measuring changes over time on a larger asset or larger site, or are they looking to do an instant ad hoc inspection? And usually if it's a large asset like a building or another facility, they're likely going to want to be able to see changes over time, as opposed to a single asset like in telecom or utilities where they want to identify an issue at that moment in time. It'll be a manual inspection with manual photos. I think that's usually where we see the difference between either manual capture or automated capture.
Yeah. Okay, cool. I'm going to hit at least one or two other questions here. So this one might be more direct and maybe a quicker answer, but this is from somebody who inspects landfills and oil fields for the government and needs to detect methane leaks. And the question is there a cheaper way of detecting methane other than with LiDAR? So I'll open that to whoever maybe has kind of dealt with that before and can offer some insight.
Yeah, we've heard some customers ask about methane detection for a while. I haven't heard using LiDAR for it, but I know like DJI has released certain methane sensors. There's some other third-party companies that have released methane detection. It's something that we hear come up very often, but usually the cost is the big barrier to entry. They're not cheap sensors by far. But if that's going to be what you're going to be doing day in, day out, and you can earn money doing it, then it's certainly worth doing it. We don't support anything internally today for methane detection. A lot of our energy customers, specifically in oil and gas, have been asking for something related to that. So we are looking into it. Generally, what I and our SE team recommend at Drone Deploy is if you're looking for gas leaks, whether it's methane or something else, in many cases, there's usually a temperature differential between that and the surrounding environment. And using a thermal camera might be more than sufficient to identify the leak, even if you can't identify the specific gas. So you can just identify there's an issue, that there's a leak, that something's running hot or cold more than it should be. And then you can send someone out to go out and inspect the issue in further detail.
Yeah, I'll echo what Jay said. I've only had a high altitude involvement in some of those POCs in the past, but if the environmental conditions are right, and you do have the temperature differential, thermal imaging, has been successful. I've seen that both in the landfill and in the oil and gas area, doing that. Some of the sniffer sensors, are less costly than OGI, which is maybe what they're referring to with the LiDAR question, optical gas imaging sensors. But if it's a high value, you got to be able to detect it, and you got to be able to determine, a particular volume, at any given time. It's going to be costly, for the equipment, for sure. Yeah.
Right. Well, I see some good, even just collaboration happening in the chat, which is part of the reason we're here, is to get people who are working on similar things together and sharing information. But maybe just one last kind of quick question for the panel here, and then we'll wrap up. Is somebody posted they've had some challenges with short flight time due to limited battery power. So are there drones with continuous flight for more than 2 hours? Is the question. Any help to provide there?
I'm not aware of any right now in a multi-rotor sense that would really reliably go past the 2-hour mark. There were some early projects and some smaller groups that were doing things with fuel cell technology, which really cut back on your payload capability as far as the cameras and things like that you could put on the aircraft. Definitely with fixed wing systems, there's a lot of fixed wing options and things I would say that are out there now that you can get up there, especially if you're not opposed to the combustible fuel. But even with battery power, groups that have started to kind of do some hybrid systems where they're putting solar photovoltaic cells on the upper surfaces of large wingspan type fixed wing aircraft, have been able to get multi-hour 3, 4, 5 hour loiter times out of those systems purely from an electric basis. But from a multi-rotor standpoint, I think the closest group that I heard that came to it was Impossible Aerospace, but I don't know. I still don't think they ever got past that 2 hour mark. So.
All right. Well, cool. We are getting close to the time here, and so I'm going to wrap it up. But I want to give a huge thanks to everybody who certainly attended and took the time to learn about the future of drone inspection and the role of data and intelligence in helping to solve real problems for real customers in the space. And also big thanks to our panelists. So Ben, Jay, Colin, thank you so much for joining us and sharing more from your experiences and your perspective. Thanks, guys. Really appreciate it.
Thanks for having
Pleasure.
us.
Awesome.
Yeah, thanks. Paul.
So we're going to post the webinar as a recording. So for folks that want to refer back or weren't able to attend but registered, can check it out. And let's keep the conversation going. So if we didn't get to a question or something piqued your interest and you want to reach out directly to somebody who is on the panel, please don't hesitate to do that. That's it for today. Thank you all so much. It was really enjoyed the conversation, and have a great rest of your day and week. Thanks a lot, guys.
Thanks.